All right. Good morning. My name is Mark Erikson, and today I am very excited to talk to you about React Redux. A few things about myself. I am an answerer of questions. You can generally find me under the handles @AceMarkE and @Mark Erikson, answering questions about React and Redux pretty much anywhere there's a comment box on the internet. I am a collector of interesting links. I have a couple large lists of links on React and Redux resources and Redux add-ons. I am a writer of very long blog posts about ways you can use React and Redux effectively. And I am a Redux maintainer. I wrote the Redux FAQ, as well as the docs section on structuring reducers, and I've actually got a little bit of the code in the library at this point. But if you're not familiar with me from those things, then you might know me as that guy with the Simpsons avatar. It's still kind of a running debate how much this does or does not resemble me, but it's close enough to get the idea across. So today I want to cover a few things. We're going to look at how Redux works with a UI layer. We're going to talk a little bit about the inspiration for the original design of React Redux. We'll spend most of our time on the history of how the React-Redux API has evolved, and then we'll talk a little bit about the future of React Redux. Now, we're already starting past 10 o'clock, and as you can see from the bottom right, I've got a lot of slides in here. I will go a little bit quickly, and there's a lot of content in here for 10 o'clock in the morning. I was asked to give a very, very technical talk, so I'm doing that. I may skip past a couple things as we go, some of the code snippets, but I will have the slides available on my blog later on, so don't worry if you don't catch something right away. You can take a look at it online later. So let's start by asking, how do you integrate Redux with a user interface layer? And that really comes with understanding how the create store API actually works internally. You can think of a Redux store as an event emitter that only has a single event. Some action was dispatched. Not even the store state changed, but just some action was dispatched. And so if you look at that example implementation of dispatch internally, you can see that all that it does is it runs your root reducer function, and then it runs all of the listener subscription callbacks. And you notice that it runs all the callbacks every time, and it also does not pass the store state into the callbacks. So when we want to integrate Redux with a user interface, there's really the same standard series of steps that you would follow every time. You create a store, you call store.subscribe and pass in a subscription callback, and inside that subscription callback, you need to call store.getState to get the current data. You need to extract the data that this piece of the UI actually cares about. You update the UI with that data. Once the subscription is set up, you need to actually render the UI the first time with the initial data, and then you respond to user input by dispatching further actions. And so every Redux UI layer is just a fancier version of this approach. So what if I want to use this inside of React? So here's a to-do list component where I'm trying to subscribe to the store by hand. And so we can see these same basic steps in action where we subscribe to the store, grab the to-dos, and then call setState to force a re-render. Same basic idea. But what if we want to start filtering the to-do list? Well, we can do the same kind of thing, but now we're having to add logic to filter the to-dos before we call setState. And we're starting to see the same kind of logic showing up when we first render the component and when we render it again. So maybe we could extract that logic into a reusable function, but what happens if the component, if we want to update or optimize how it's re-rendering? We could add some logic to manually check if the filtered data has changed at all, but this starts to get very, very complex. Why would you want to write this kind of code by hand in every React component in your application? And so this really is the point of the React-Redux Connect API. It generates wrapper components that handle this process of subscribing to the store, extracting the data that your component cares about, and only re-rendering your component when that data has actually changed. A couple years ago, Dan Abramov put together a small gist where he showed a miniature version of Connect. And this is that code snippet from the gist. And so it shows that Connect accepts map state and map dispatch as arguments, returns a second function. The second function accepts your real component as an argument. And then it's going to render an instance of your component, pass in the props from the wrapper, and the props generated by the map state and map dispatch functions. When the wrapper component mounts, it subscribes to the store. When it unmounts, it unsubscribes. And whenever an action is dispatched, it's going to force a re-render. So this is really the guts of Connect right here, at least conceptually. So the key points are that Connect generates a wrapper component for you. The wrapper gives your component props based on the Redux store. Every component subscribes to the store, and this wrapper really abstracts away the process of interacting with the store so that your own code doesn't have to subscribe to the store itself. You just say, here's the data that I need, and Connect takes care of it for you. But what does all this even look like inside? So back in 2015, when Dan Abramov was first creating Redux, he extracted the React-Redux content into its own repo, and the first issue he filed asked, how can we settle on a final API for React-Redux? And he listed a series of constraints that he felt that this API should follow. And so you can see things like you should be able to connect to state anywhere in the component tree, or you should be able to handle updates from the data. You should be able to define a function that extracts the data, and we should have performance optimizations with should component update everywhere in the tree. So over the next couple weeks, they iterated very rapidly on the API, and it hit 1.0 by August. There were a couple more small breaking changes over the next couple months, and by October, just a couple months later, we'd hit version 4, and that's where things basically stayed stable for the next year and a half. So let's look at some of the actual details of some of these implementation versions. So in version 4, every instance of a connected component is a separate subscriber to the store. So if I have a connected list with 10 connected children, that's 11 separate calls to store.subscribe, and 11 different callback functions that run every time an action is dispatched. Another very key point is that the UI updates require store state immutability. So the components are going to check to see if the root state changed at all. They check to see if the output from your map state functions have changed. And then they check to see if the merged props have changed at all. Now, how many of you have ever accidentally mutated state and then your components didn't re-render afterwards? Okay, quite a few people. This is the reason why that happens, because if the components think that the data hasn't changed to a new reference, they assume nothing changed, and therefore there's no reason to re-render your React components. Another key point is that in version 4, the store instance was passed down via React's legacy context API. And now the context API makes data available to deeply nested components, but it actually had a flaw. It would not properly update changes to values. But if you put some kind of an event emitter into the context, nested components could subscribe and they would receive updates even though the reference, and because that one emitter reference wasn't changing. Another interesting outcome of this is that the connected components could accept a store as a prop, and they would subscribe to this directly. Now, that was mostly used for being able to unit test connected components without having to put a provider around them. In version 4, the actual logic for updating things when an action was dispatched was directly inside the component itself. And interestingly, most of the logic actually lived in the render method of the wrapper component. An interesting side effect of this is that it meant that anytime an action was dispatched, all the wrapper components actually had to re-render to determine if your component needed to render or not. And because of this render process, they needed some way to avoid updates to the child, because React's default behavior is that when a parent component re-renders, all of its children re-render. So how can we bail out if the child doesn't need to be updated? Well, there's a little trick that you can use. React elements are normally new objects every time you render. But if you return the exact same child element by reference from the render method, React will bail out and skip updating those children. And so version 4 used that process as an optimization. So I have a few code snippets here. In the interest of time, I'll skip past these. But these snippets highlight some of the key parts of the actual implementation details. So you can check those out in the slides later. So let's look at version 5. So by the middle of 2016, Dan Abramov had joined the React team and was very busy with that. And I had gotten involved with the Redux project. And Dan gave the maintainership of that to myself and a guy named Tim Dorr. And shortly after that, a user contributed a couple issues and PRs where he offered to rewrite all of Connect from scratch. And the first time he filed that issue, I was like, that's interesting. Why would you want to do that? What we have works just fine. But we kept talking and iterating through this process, and he eventually proved that his version was a lot better in a lot of ways. So we iterated on that through the rest of the year, and by the end of 2018, we published this implementation as version 5. And it actually did have a lot of performance improvements, and it fixed a lot of bugs in the process. So some interesting points about version 5. Version 4 had a lot of recurring bugs that would only happen in certain edge cases, where it was possible for a child component to subscribe to the store before the parent. And if something happened like data for a list item was deleted, the child might try to read that data from the store even though it was gone, and that could result in an error being thrown from the map state function. I refer to this as the zombie child bug problem. And so in version 5, we fixed that by using this internal subscription class to cascade the notifications step by step down through the tree. And so this fixed the problems because we ensure that a parent component always subscribes to the store before the children do. And so if an item gets deleted, the parent will stop rendering that child before the child can run its map state function. So this was a really big help. Version 5 also added something called Connect Advanced. This was really the guts of Connect, but less opinionated about how to turn store state and wrapper props into the actual props for the child component. Now, it's interesting because on the one hand, we re-implemented Connect as a certain set of options to Connect Advanced. On the other hand, almost nobody uses this. And in fact, there's some recent discussion. We're probably going to deprecate and eventually remove that function because no one even knows it exists. Another interesting point about version 5 is that all the logic for determining if the component should re-render has been moved outside of the component itself and into a set of custom memoized selector functions. And so all the logic of running your map state and map dispatch and calculating the new child props actually happens outside of the React component tree. And we only actually get React involved once we know that the child component needs to re-render. And this is ultimately the reason why version 5 was a lot faster than version 4. So we will skip past the code snippets again and move on to version 6. So version 5 came out at the end of 2016 and lasted for a couple years. But by early 2018, we started having some discussions with the React team about this new concurrent mode thing that they were talking about. And Flarney will be talking about that shortly and give a lot more detail on that topic. And so one of the big concerns that the React team expressed was this idea of tearing. What if during one render sequence, part of the component tree reads data A from the store, an action is dispatched in the middle, and now the rest of the tree reads a different set of data from the store? You would have two different parts of the tree rendering with different data. And Andrew Clark especially expressed a lot of concerns about this problem. Version 5 also threw a number of warnings in React's strict mode. And when we tried to eliminate those in a modified version 5, the performance was abysmal. We couldn't fix it. And finally, React had released a new version of their context API in 16.3, and we wanted to switch over to that. So our goals for version 6, we wanted to switch from old context to new context. We wanted to fix the strict mode warnings. We wanted to drop the very clunky ref forwarding implementation that we had. And we had the general goal of maybe we can be more compatible with concurrent mode somehow. So I collaborated with a user named Greg Beaver on the version 6 implementation, and we both kind of came up with our own separate approaches for how this might work. We did some comparisons and eventually settled on Greg's implementation as the final version. And so we put out version 6 at the end of 2018, 2 years after the release of version 5. So one of the biggest changes in version 6 is that rather than having every component be a separate subscriber to the store, we only had one subscriber, and that was actually in the provider component itself. And it actually passed the entire store state down via React's new context API. And part of the reason for this was that by having the entire component tree always seeing the same copy of the store state at the same time, it would eliminate that tearing problem. In addition, because React always re-renders top-down, we actually were able to drop that custom subscription class code because that's just how React updates anyway. And the new context API always propagates updates even if you have components that skip updating. So I thought, this is great, it's all built into React, it works for free, we can simplify our own code base. We still use the same selector functions as version 5, but now we actually had to call them directly in the render method of the wrapper component again, because you can only access data from context directly in there. And so we wound up using that same memoized child element trick from version 4 to try to optimize how the components re-render. We also dropped our with ref option and used React's new forward ref API so that you could just put a ref on the wrapper component and actually get back your own component instance as a result. So that brings us up to version 7. When version 6 was in development, we had some concerns about performance. And so I put together a benchmarks repository that would try to compare version 5 and version 6 and try to make sure that things didn't really get slower. But during the benchmarks and the development, we saw that version 6 was actually slower in several of the scenarios. Now, these were very, very artificial stress test scenarios. It's like, how many components can I render on screen before it starts to slow down in some way? But the goal was to have some kind of objective numbers that we could compare. So what we saw was that version 6 was slower in these stress tests, but our hope was that in real-world apps, we could put it out and there wouldn't actually be a difference. But after version 6's release, several people did file issues and said that in their actual real applications, they did see slowdowns of some kind. So we started investigating those performance issues. And it really comes down to how version 5 and version 6 handle updates. In version 5, every component subscribes. The checks for updates are done outside of React, and React only gets involved once we know the component needs to re-render. In version 6, we always have to get React involved because the provider is calling set state every time there's a new state value. And so that means there's a re-render working top-down, even if no components actually care about the change to the state. And so even if React isn't doing a lot of work in that render, that's still a lot more work than just running a couple of selector functions. There were also some concerns about the fact that there was no more store as a prop in version 6. Since the connected components didn't subscribe themselves, there was no point in having store as a prop, and so we removed that. And some users expressed concerns that they couldn't test their connected components effectively. And finally, this was a blocker for our ability to maybe create some kind of a Redux hooks API, because context always causes that component to update. There's no way to avoid re-rendering when the context value changes. And there was a mile-long thread in the React repo where we were discussing with some of the React team members what an API for avoiding updates from context might look like. And eventually, Sebastian Markbaga said, "My personal summary is that new context is ready to be used for low-frequency updates. It's not ready to be used as a replacement for Flux-like state propagation," which was a problem because we were using it for Flux-like state propagation. So that was a problem. So in early February of this year, I published a roadmap issue saying, okay, we're going to come up with a version 7, and we're going to fix these problems. I don't know how we're going to fix them yet, but we're going to fix them somehow. And so the primary goals were run at least as fast as version 5, fix the problems with store as prop, hopefully work okay with Concurrent React, but maybe not because it's not out yet, hopefully avoid the zombie child issues, and hopefully act as a foundation for eventually building a hooks API. So I wound up building the alpha on this entirely by myself. I just had a couple weeks free. I was able to hack on something and put it together. And again, after a lot of discussion and iteration and alphas, we eventually put this out as a final release in April. And that is what's out there right now. So the key points for this one, we brought back direct subscriptions. So every connected component is now subscribing to the store directly again. That did mean that we had to bring back the custom subscription class that we had from version 5. In fact, I literally copy and paste it from the version 5 code tree. And so the result of this is that version 7 is at least as fast as version 5 in all of our benchmarks, if not faster. The other really interesting thing is that Connect uses hooks internally. Previously, Connect was a class component, and now it is a function component that uses hooks. The other really interesting thing here is that we now use React's batched updates API internally. Many of you have seen that if I call setState more than once in a click handler, React will group those updates together into a single render. And that's because React wraps your event callback with this batched updates API. And so we now actually use that inside of Connect so that the updates caused by the Redux dispatch are actually batched together and cause fewer internal re-renders. We also now re-export that function as part of our public API so that if you're dispatching multiple Redux actions outside of React, like in a thunk or something, You can now wrap those in this batch call, and it should only cause one re-render instead of multiple re-renders. So let's actually look at a couple of these code snippets real fast. So you can see that connect itself is now a function component that uses hooks internally for its implementation. You can see some fun logic for actually running that selector and trying to calculate what the new child props should actually look like. And we actually have to force a re-render when an action is dispatched and we've calculated that the child props have changed. And finally, we do actually use that same memoized child element trick, except that this time we can now use React's built-in use memo hook to do that work rather than trying to memoize that logic in some separate way. So that brings us up to version 7.1. When hooks first came out, the React hooks FAQ said that other libraries might want to provide their own hooks, like maybe some kind of a use Redux hook or something like that. And so like 30 seconds after the announcement, issues were being filed on the React-Redux repo saying, when are you going to give us hooks? But we had to get this version 7 done and out the door before we could even really consider what a Redux hooks API might look like. So there was very, very strong demand from the community. In fact, at one point, I put up a poll on Twitter saying, so now that version 7's done, what would people like me to focus my time on? Should I work on a React Redux hooks API? Should I work on improving the Redux docs? Should I work on Redux starter kit? And like 85% of people said, hooks, hooks. It's like, okay, I can take a hint. So there were several questions that we had to solve. What would the actual API even look like? How do you handle selectors that need to depend on props for the component? How can we avoid this zombie child bug again? And like, what if some solution that we come up with maybe requires ES6 use, like proxies? So we had several very, very long discussion threads, like over 200 comments apiece. And after comparing a lot of existing third-party implementations and some suggestions from the community, we eventually settled on an implementation from a user named Jonathan Ziller. And we put out our first alpha back in April. And the initial alpha had 5 different hooks: use selector, use actions, use Redux, use dispatch, and use store. And we continued to iterate on the API as we went through a couple more alphas. We dropped the use Redux hook, which basically was the equivalent of use selector plus use actions, like connect, because it really didn't provide any real benefit. We also dropped use actions because Dan felt that it was too much overhead and not really helpful when used in a hooks kind of a world. And we also changed how use selector calculates its equality to determine if a re-render is actually necessary. So after multiple iterations, we put out a release candidate in late May, and we've been waiting to hear a bit of feedback on that. And so, what do these hooks actually look like in action? So you still need to put a provider around your entire app, same as always. But as you can see over on the right, we now have a use selector function where you can extract data from the store. There is a use dispatch hook that gives you the store dispatch reference directly. And so then I could say create a click handler where we call dispatch and use some kind of an action creator. So hopefully it's fairly simple and lightweight and should work pretty well in your applications. And that's why I am pleased to announce that as of late last night, React Redux version 7.1 with hooks is now final. Woohoo! So, I will say that as a maintainer, I have discovered that no matter how much you ask for feedback during an alpha or a beta, the best way to get feedback on anything is to publish a final version, at which point everybody starts filing issues that something is broken. So, given that the code here is relatively simple, I'm hoping there won't be many issues, but please try it out in your own applications like today and tell me everything works just fine, okay? So what does the future hold? We're still really not sure exactly how this React concurrent mode thing is going to work out. Hopefully Fernie can answer some of those questions for us. It's very possible that React Redux and concurrent mode might not play all that well together. We don't know. We're going to have to wait and see. As far as actual changes to the library, we're kind of hoping that we won't need any more changes for a while. But if there is, keep an eye on the issues. I'm sure there will be discussions. All right, I am out of time, and I actually managed to finish things without having to hurry too much. So my slides have links to some additional discussion and information from the docs. I'll have those up on my blog, hopefully sometime later today. Thank you very much for your time, and enjoy the conference.